Okay, very good morning for everyone. My name is Kishan Rao from class DKA2A, and my matrix number is F1043. And as you can see today we're going to do a video about my assignment 1 from diploma in civil engineering, and the course name is DCC 200053 Mechanics of Civil Engineering Structures. And as you can see, this is my question, and this is a question 2. Let's read the question. A cantilever beam with an unsymmetrical I section as shown in figure 2 is subjected to point of load. If maximum bending moment on the beam is 40 meganewton mm, please answer the following questions. Okay, there are among almost 4 questions that I have to answer, and this is the graph, more like the picture for my solutions. And as you can see here, I have already done most of them. This is number 1 and this is number 2 and this is number 3. But as for the number 4, they asked me to do this, and I'll read the questions. They said, based on question 2, please construct the process of creating the bending stress diagram through a formal presentation or interactive video, and which is what I'm doing now. To demonstrate your understanding and drawing skills regarding bending stress, please refer to rubric as attached. Okay, as you can see, they are asking me to do a video on this question 4, showing how to maybe demonstrate my understanding and drawing skills. Okay, so today I'm going to draw the bending stress distribution diagram for cantilever beam using the method, correct method. Well, for first, take a piece of paper, and you need a ruler. Give me a sec. Alright, so first let's write the title, which is bending stress. This bending stress distribution diagram for cantilever beam. Alright, that's good enough. Okay, next let's take a ruler, and let's first do this. Put a line half to the paper, and let's like this too. I hope you can see this. I'm very sorry if it's not clear. Oh yeah, that's perfect. And down here too. Oh yeah. So in this side we are going to draw the I beam, and in this side we are going to draw the graph of how the graph of the distribution diagram. Okay, first, so this is where we're going to draw the I diagram. So let's draw it nicely, like this. 1, 2, 3. Let's make some beautiful lines here too. Oh yeah, that's perfect. Okay, alright, this is our I diagram. This is how the I diagram will look. And as for this, let's do this. Let's make an X and Y axis. Alright, perfect. Now let's label this as Y. Let's label this also. Alright, now that the drawing the I-beam and the graph has completed, let's look at this. So we're going to do it like this: 1 2 3 4 5, 1 2 3 4 5, here to here. Perfect. So let's take our ruler and just draw a straight line. Okay, the reason why I'm drawing my line like this is because this is a cantilever beam, and for cantilever beam usually the tension will be here and the compression will be here. Alright, let me label this as a tension, and let me label this as compression. Good. Now let's make the arrows like this, because this is how usually the arrows will go for tensions, and like this for everything. I'm sorry if it's messy. And let's just make line. Just be with me for a while. I'll be over in a quick. Okay, after making lines like this, let's draw some symbols like this. Okay, that's nice, good. And for everything, for this side, same like this. Okay, so as you can see, no lah. ಎಲ್ಲ ಕಟ್ பண்ணிட்டு ಇದು ಮಾಡ್ತಾರೆ. As you can see, I hope this is clear. Alright, this is our I-beam and this is how our graph has turned out. And yes, this is our bending stress distribution diagram for cantilever beam. Thank you very much for watching, and hopefully it's not that messy and it's understandable. Thank you for bearing with me. And next, there's no next, but let's just take a look at this C question. Maybe most of you all might be confused as to why I've drawn this tension and compression here, but yes, the questions initially they asked for maximum bending stress of compression and tension. And when it's about compression and tension, the formula that we'll use are this, which is M per I over Y, the Y over Y, both for both C compression and tension. And as you can see here, it might be same, but there is a little difference. As you can see in this there is this 300 mm. Okay, can you see? Yep. And if you see for this tension, there is no 300 mm. Now you all might be confused. Why is the compression was minus with 300 mm and the tensile was not? Well, the quick explanation that I can give is, let me go like this. So let's say this is our cantilever beam. Okay, so in a cantilever beam, this one will be tension and this one will be compression. So when the load hit here, the beam will come like this, will bend like this. No, it won't bend like that. The beam will bend like this. Yeah. So when this happens, right here, there's a high chances of it breaking, and this is because this is the compression side where all the stress goes inside, and this is the tension side, tension side where all the stress goes outside, leaving there's no damage in here, while all the damage is being put it here. So now what we want to find is, we want to find the distance or resistance from here to here, and in order to find that, we need to minus this thing with the height of this thing. And as you can see, the height of this thing is, let me show you, the height of this is 300, and thus the compression, when this, because this is 300, when finding the maximum bending stress for the compression, we had to minus 300, and we don't have to minus anything for the tension because there is no damage for the beam on the tension side. I hope this clears any misunderstanding or doubts, and I hope that this makes it more easier to understand why the graphs are like this. And you can see here, all the tensions are going in and all the compressions are going in, while the tension is going out and the compression is coming in. Yes, and that's all. That is my task to do the video about SM1, and I hope that it is achieved successfully, and I hope I didn't disappoint anyone. But thank you for bearing with me. Thank you.